Hey, it's Mr. Estrada here, and our learning target says I can apply the properties of parallelograms in the coordinate plane. So in today's video, we're going to be doing some proofs in the coordinate plane, and it's going to deal with parallelograms. So before I go to the first example, I just want you to know that I'm only going to use the slope formula in this video for the proof that I'm going to work out. But there are other ways to prove parallelograms in the coordinate plane, but I'm going to exclusively use the slope formula. So if you want to prove a parallelogram in the coordinate plane, I'm giving you a procedure here and a sample statement, and I do the same for a rectangle and a rhombus and a square. Okay, so here is our first example and our only example. It says the vertices of quadrilateral JKLM have coordinates J, K, L, and M. Prove that JKLM is a parallelogram, and then prove that JKLM is not a rhombus. The use of the set of axes below is optional. So if you go back to this slide here, I'm telling you that if you want to prove a parallelogram, demonstrate that the opposite sides are parallel, and that means you're going to have to use the slope formula 4 times. So I'm going to go ahead and do that. So with these proofs, there's going to be an evidence portion, and then there's also going to be a statement portion. Let me find the statement part right over here. The evidence is the work that you do, and then the statement is what you're going to write. So let's go ahead and just graph this figure. J is -3, 1. So let's go ahead and plot that. My computer is running very, very slow. -3, 1 is 1, 2, 3 right over here. K is 1, -5. 1, 2, 3, 4, 5 right over here. L is 7, -2. And that will be right over here. And M is 3, 4. 1, 2, 3. 1, 2, 3, 4. And connect. So there is a line. That there's M. K is here somewhere. Let me just pull it up. There it is. And L is here somewhere. There it is. Alright, so there is JKLM. And I apologize for my very, very slow computer. Alright, so the evidence part is going to be the slopes that I find. So let's go ahead and find the slopes for each individual one. I went ahead and did that already. There's a slope of JK, there's a slope of ML, and if you're wondering if you have to show the work for each of the 4 sides, the answer is yes, you do have to show the work for each of the 4 sides, because it's a proof, so you have to give evidence. Alright, so what can we learn from our evidence here? Our evidence is telling us that the opposite sides are parallel, right? It says that JK and ML have the same slope, so we could say JK is parallel to ML. And the evidence here says KL is parallel to JM. So what we could conclude from that is that the figure is a parallelogram. So I'm going to write a statement saying that. I'm going to say JKLM is a parallelogram because its opposite sides are parallel. And the evidence is right over here. This is my evidence, the slopes. Alright, now I have to prove that the figure is not a rhombus. And again, there are many ways you could do that. You know, if you want to use the distance formula and say all the sides are not equal, that's another way to do it. But remember what I said in the beginning of this video, I'm going to exclusively use the slope formula for my proofs. So if I want to prove this is not a rhombus using the slope formula, I have to show that the diagonals are not perpendicular. So that means I need to find the slopes of the diagonals. So I'm going to have an evidence piece and then later a statement piece. So here is my evidence. The slope of the diagonals JL and KM. So here is JL. It has a slope of -3/10. And here is KM. It has a slope of 9/2. So from that, you could see that these slopes are not negative reciprocals. Not negative reciprocals. And what that means is that these lines are not perpendicular. The diagonals are not perpendicular. So if the diagonals are not perpendicular, then we know the figure is not a rhombus, because that's one of the properties of a rhombus. So I can make the following statement. I'm going to say JKLM is not a parallelogram because the diagonals, it is a parallelogram. I need to correct that. JKLM is not a rhombus. Let me go ahead and fix that. JKLM is not a rhombus because the diagonals are not perpendicular. And we are finished with our proof. Let me see if I could just fit this all on one page. Maybe zoom out a little bit more. All right, so first we had to prove it's a parallelogram, and we did that by showing that the opposite sides are parallel. Right? If the slopes are equal, the lines are parallel, right? Equal slopes means parallel. So we showed the opposite sides are parallel, then we could say the figure is a parallelogram. Then the second part was prove it's not a rhombus. And so to prove it's not a rhombus, we showed or demonstrated, gave evidence that the diagonals are not perpendicular. And the evidence of that is that the slopes are not negative reciprocals. All right, so that's it for today. Hope this video helps. Have a great day.